Welcome to this video where we're breaking down the reflex, the simplest and most direct response in the nervous system. Reflexes allow your body to respond almost instantly to certain stimuli, often without needing to involve the brain. In fact, reflexes are fast, automatic reactions that typically involve just the spinal cord. Today we'll explore how these quick responses happen and what makes them so important. A reflex is an involuntary motor response to a sensory input. It happens automatically, without conscious thought, and usually takes place in the spinal cord. Because reflexes don't require brain involvement, the reaction time is incredibly fast, allowing your body to respond to potential threats or changes in your environment almost instantly. One of the most well-known examples of a reflex is the muscle stretch reflex. You've likely experienced this at the doctor's office when they tap your knee with a reflex hammer. This is called the patellar reflex, and it's a classic example of how a monosynaptic reflex arc works. In a monosynaptic reflex arc, pathway is incredibly simple. It involves just one synapse between a sensory neuron and a motor neuron. When the doctor taps the knee, a sensory neuron detects the stretch in the quadriceps muscle. This sensory neuron transmits an action potential directly to a motor neuron in the spinal cord. The motor neuron then sends a signal back to the quadriceps muscle, causing it to contract and resulting in that familiar knee-jerk response. This rapid feedback loop is what allows reflexes to be so quick. There's no need for the signal to travel all the way to the brain, but reflexes are often a bit more complex than just one muscle contracting. For example, in the patellar reflex, while the quadriceps muscle contracts, the opposing hamstring muscle has to relax to allow your leg to fully extend. This coordination is achieved through a process called reciprocal inhibition. Here's how it works. When the sensory neuron is activated by the muscle stretch, it not only stimulates the motor neuron for the quadriceps, but it also activates an inhibitory interneuron. This interneuron inhibits the motor neuron that controls the hamstring, causing the hamstring to relax. Even though reflexes happen automatically and involve the spinal cord, we are still aware of them after the fact. That's because sensory neurons also send signals to the brain, providing us with information about what's just happened. So while the reflex itself is unconscious, we are made conscious of it moments after it occurs. This awareness is useful for understanding the reflex and any subsequent actions we might need to take. Not all reflexes are as simple as the monosynaptic reflex arc. Many reflexes involve more complex pathways that include interneurons and multiple synapses. An example of this is the withdrawal reflex, where you quickly pull your hand away from a hot surface. This reflex involves several interneurons in the spinal cord, which allow the sensory signal to activate the motor neurons that control multiple muscles. In this way, you can quickly remove your hand while maintaining balance. Reflexes are vital for our survival. They protect us from harm, help us maintain posture, and enable us to perform everyday tasks like walking or grabbing objects. Reflexes also give doctors insight into how well the nervous system is functioning. For example, abnormal reflexes can indicate problems with the spinal cord, nerves, or even brain function. To sum it up, reflexes are the nervous system's fastest and simplest responses to stimuli. In the monosynaptic reflex arc, sensory neurons directly connect to motor neurons, making the reflex incredibly quick. More complex reflexes, like the withdrawal reflex, involve interneurons to coordinate multiple muscle groups. Reflexes are fundamental to how our nervous system works, allowing us to react almost instantly to our environment without even thinking about it. Understanding how these rapid, automatic responses happen helps us appreciate just how efficiently the body protects itself and maintains function. And for more deep dives into topics like this, check out our app, King of the Curve, or visit kingofthecurve.org for more content that'll help you master the material. Don't forget to subscribe for more in-depth videos, and let us know in the comments if there's a topic you'd like us to cover next.